your June 23 paper, June 23 M1. Okay. So I'm going to do all the questions of this paper just selectively. I think whatever the question is from your vector, we'll just cancel that. Otherwise, we'll solve all the questions. So for the first question, it says this is about collision. So this is about your momentum concept. First one says a particle has mass 4 kg and the particle B has a mass 2 kg. The particle moves towards each other in opposite direction along the same straight line on a smooth horizontal table and collide directly. Immediately before the collision, speed of A is 2u and B is 3u, and after collision, speed of B is 2u. The direction of B is reversed by the collision. So in terms of u, find out the speed of A immediately after the collision. Okay. So first is that we have to draw the entire scenario before collision and after collision. I know that before collision, they were moving in opposite direction. One thing to understand, this type of pathways are like, very narrow. If they are very narrow means that if one particle is reversed, that means obviously the other particle would continue to travel on the same pathway. Like, this is how their pathways are. Very, very narrow pathway, and only one entire ball will take up the entire space of your pathway, right? If that's the case, then what happens is that there is this one ball, and then again there is this another ball, right? If they were before the collision heading towards each other, after collision they're saying that B reversed its direction. That means obviously A was traveling to the right hand side, that's why B reversed its direction, right? That's what happens. They hit each other head on collision, and then again because of forces acting on B and A, B reverses its direction and A just continues to move in the same direction, but maybe now at a smaller speed. Just 1 minute. Okay, so in this case, what I was given the information is about is that, we have informations about their initial velocities. I'm considering this as B, this as A. Particle A was moving to the right with 2 meters per second, and B was moving to the left with 3u meters per second. Their masses was given 4 kg, and then this was as 2 kg. Right after the collision, what happens? Everything is similar, only B reverts its direction, right? To be honest, whatever I know that, okay, according to my assumption that this is a narrow pathway, they were moving, like before collision, they are moving towards each other, and after collision, if B reverts its direction, means that according to my assumption, my understanding, that A must have traveled to the right hand side. That's why B had to reverse its direction, right? So in that case, I don't know the final velocity of particle A, but I know that final velocity of particle um, B was 2u meters per second, and the direction reversed. Right. According to my assumption, I am assuming that this was again traveling. This was still traveling to the right hand side. So for this, if I want to calculate the value for your A, right, in that case, what we have is that obviously we are taking direction towards right as positive, and in that sense, total momentum before collision is equals to your total momentum after collision. So for your total momentum before collision, what do we have? 2u4 and then 3u minus 2, right? Then again, this one is just going to be considered as velocity. We don't have the magnitude for it. So we just need to write 4v and then 2u2. So you have minus 6u, 4u. So that's 2u and 1 minute. Yeah, that is your 2u. So again, this is your 2u, 4v plus 4u. And eventually, if you just take every u's together, so you have 2u, 4u, which is 2u. So you have v as right, this is your negative half u. So now for this kind of cases, right, if v is equals to negative half u, problem is that obviously if I was working with speed doesn't have any problem. Speed will just focus on the magnitude, which is just half u meters per second. This is your part A. In part B, now they're asking for the direction. According to your assumption, the maths gave you a negative value. That means your assumption was wrong. I assume that particle A would still continue to move to the right hand side, but my math says that no, particle A would have also reversed its direction. Not B only reverses its direction, A also reverses its direction and now is moving to the left hand side. Right, that's why my maths gave a different answer. Maths gave a answer in terms of negative. You considered A to be traveling to the right hand side and considered right to be positive, and they gave you a negative value for V. That means in real life, A would have traveled to the left-hand side in the opposite direction to which you considered it to be positive. That's why over here, for your part B, if I want to talk about the direction of particle A after the motion, after the collision over here, so direction will be, uh, direction is reversed. Right, and we can understand that by the negative sign from our calculative parts. Is this clear? Any problem from this part A and B?
No, teacher.
Okay, then for part A, B done. Finally, they're saying in terms of U, find the magnitude of the impulse received by B. You have to understand that who is receiving this? Particle B is receiving this, right? That means obviously I'm going to use particle B's information over here. So if I want to use particle B's information, this is easy. Particle B before collision. I mean, if I just draw one diagram, before collision, it was traveling to the what hand side? To the left hand side, right? Yeah, to the left hand side with 2u meters per second. Then again, after collision, it was moving with 2u. So this was actually at 3u meters per second. Then again, 2u meters per second. And mass is just 2 kg there. This is it, right? Now, if I want to find out the impulse, it's going to be just mv minus mu. That is 2. If I consider right to be positive, so obviously this is positive and this is negative. So it turns out to be minus 2, 3u. Oh, wait, 1 minute. This is final velocity, right? So 2u minus 2 minus 3u, which is now going to be 4u plus 6u. That is 10u, right? 10u kg meters per second. Yeah, 6 and 4. Yeah, this is 10u. Again, for particle B, the impulse came out to be positive because obviously during the collision, when particle A and particle B were colliding with each other, B and A, particle A exerts a force on particle B to the right hand side, and that was considered to be a positive direction. And particle B exerts a force on the left hand side, which was considered to be a negative direction. So if I was calculating the impulse for particle A, right, impulse on particle A, that would have came out to be negative 10u. And that's why the particle for B, if I want to find out the particle for the impulse for the particle B, this one gives you a positive value because we're taking direction towards right as positive, the extra force acting on particle B is to the right, that's why impulse on B is also right. So this is it for your part 1, all the informations you have to do for your question 1.
Can you explain
Any
here?
problem from this part?
Can you explain
Sorry,
that part
Asri.
again? The
Oh, in
impulse.
the last part, in the last part, what happens? When impulse is only exerted onto the each particles during the collision, right? So when particle A is in collision with particle B, Particle A exerts a force to the right hand side of B. So this force acting on particle B will have a plus sign because we are taking direction towards right as positive in our maths, right? And then again, obviously, with respect to this particle B will also exert a force in the opposite direction on A. Now this is to the left hand side, so that's why it has a negative sign. And in this sense, the impulse that is acting on particle B will have a plus 10u, and the impulse that is acting on A will have a minus 10u. Is this clear?
Yes, teacher.
Right. So that's why, according to your maths, also the impulse on B turns out to be positive 10, not negative over here. So this is it for your question 1. Now, if we move on to your question 2. The problem is that this question is actually a vector case. This is actually an example for vector, but we can still calculate this. It's just easy vector, like you have to add and all these things. It says that a particle P rests in equilibrium on a smooth horizontal ground. The system of three forces, F1 Newton, 2 Newton, 3 Newton, acts onto them. And out of this, F1 Newton and 2 Newton is given and is applied onto a particle P, and P remains in equilibrium. Remains in equilibrium means that resultant force is equals to zero. Even after adding the three forces, they will eventually cancel each other out. So now they're asking that try to find out F3 in terms of C, I, and J. So which is easy. With three forces act, and given that P remains in equilibrium, find F3 in the terms of I, C, and J, right? I mean, yeah, over here you just have to consider it in this way, that if the object is in equilibrium, part A, obviously resultant force is equals to 0, and your F1 plus F2 plus F3 is equals to 0. In that case, you just have to make F3 the subject. So it will be minus F1 minus F2, which is, by the way, how much is your F1? 3I 4C, 3C 4C, 1 minute. Yeah, 3C 4C. And then again, you have this 14I 7J. Right. So you basically have minus 3CI minus 4CJ plus 14I minus 7G. So take all the I and J together. So eventually you have 14 minus 3CI and then again minus 4C minus 7G. So this is an expression for your F3, right? This is a part of your vector calculation, but not that much specifically. Like we understand how to do all these things, right? This is enough. Now, is there any problem from this part E, Azri and Fayad?
No, miss.
Okay, then this is for your part A. For this one, in the next case, they are saying that now the force 3 is removed from the system, and it is also given that C is equals to 2. Now find the size of the angle between the direction I and the resultant and the direction of the resultant force acting on P. We have to understand that what do we mean by direction I? Direction I means positive x-axis, right? Always I and J are horizontal and so in this question, I and J are horizontal perpendicular unit vectors. Horizontal perpendicular unit vector means that, this is your idea, that this is your positive I, this is your positive J, and then obviously in the opposite direction is you have the negative I and negative J. So this time, if they're saying that, there is, F3 is entirely removed and C has a value of 2, so try to find out the resultant force. So obviously, I can understand that for part B, resultant force is just F1 plus F2. How much will be the value for F1? F1 is now is 3 into 2 is 6, right? So 3 into 2 is 6. In that case, you have what? 14 minus 6. I mean, this is the expression that, by the way, we are supposed to get. 14 minus 6i, and then again
Teacher,
minus this is going to be, yes, Asri?
shouldn't it be 4C plus 7J?
4c, so yeah, this one is going to be plus 7j, okay. Then this one's going to be over here, how much? 8 plus 7, right? So which is 8 plus 7, that is 15. I'll just write 8 plus 7j. So after this, you end up getting 8i minus, yeah, we end up getting, 1 minute. Oh wait, this is actually problematic because over here we consider them to be all negative, right? So that's why this one will have a minus sign and this one will have a plus sign in front. So then let's just easily calculate it. For example, 3ci minus 14. So 3c minus 14i, and then again plus 4c, and then plus 7. So we have 4c plus 7g. So now inside the c, so we have 6 minus 14, that is minus 8i, and then again 8 plus 7 is your plus 15g, right? So this is the value for your RF, resultant force. Now again, this resultant force means what? Negative 8 in the negative x-axis and 15 in the positive y-axis. And I was trying to find out the angle it was creating with the x-axis. So I have to create a axis diagram like this, and your vector is somewhere here, right? Because it has a negative 8 magnitude and positive 15 magnitude. So it creates a triangle like this, right? This is where the vector has a coordinate of minus 8i and then 15g. And if that's the case, so your negative, when this value is actually 8 and this height is actually your 15. And if I want to find out the value for this theta that they were trying to calculate, 1 minute, they never ask you to find out the bearing. If they would ask you to find out the bearing, then I'll have to calculate the angle directly from the north plane to this line, right? But since they only ask you to find out the angle it was making with the x-axis, so only with this theta is enough, right? Another thing, the angle that you are showing here is actually the angle it is creating with the negative x-axis, but the question was asking you angle with the positive x-axis, right? So the question was actually asking you to calculate this value, not the theta. So one thing that I'm going to do over here is that first I'll calculate theta, then I'll subtract this from 180 to get to the value for your angle it was creating with the positive y-axis. So in that case, if I want to calculate theta first, it's just going to be tan inverse 15 by 8. So tan inverse 15 over 8, and then again subtract this from 180 to get the value for your alpha. So you get alpha as 180 degree minus tan inverse 15 over 8. So which is going to be 170, wait, sorry, my calculator was in radian mode. 118 degrees. So you can write your answer as 118 degrees as the value for your alpha. Is there any problem from this part?
No, teacher.
Okay, then if we move on to your next part. In the next part, it says the mass of particle P is m and the magnitude of the acceleration of P is 8.5. Find out the mass. I can already understand that if the resultant force was at 8 and 15, how will I find out the magnitude of the resultant force? So I just have to find out the modulus of that resultant force. By the way, for this one, again understand we have a 8 and 15. If I want to find out the length of this, I just have to use Pythagoras theorem, right? 8 square plus 15 square gives you resultant force square. So we just have to find 8 square plus 15 square everything under the square root, and that will give you the value 8 square plus 15 square, which is 17. And now just use the equation like, RF equals to MA, where M is, by the way, 17 over acceleration. What is the value for acceleration? That's 8.5. So you have 17 over 8.5. So you get 17 over 8.5, that is 2 meters per second square. So you get the value for your mass as 2 meters per second square. So this is the value for your part C. Is this clear?
Yes, ma'am.
Okay, then in that case, this is it. After this, if we move on to your next question, we're done with this question too, by the way. Right, we calculated the F3, then calculate the resultant force. If we remove the F3, what angle they're creating with the positive x-axis, and then again we calculated the mass using the modulus of RF and acceleration. So after this question is about what? Kinematics, I think, right? Yeah. This one says two students observe a book of mass 0.2 kg fall vertically from rest from a shelf that is 1.5 meters above the ground. Okay, so two students observe a student of mass 0.2 kg fall vertically from rest from a shelf that is 1.5 meter above the ground. Student A suggests that the book is modeled as a particle falling freely under gravity. A student use student A's model to find the time taken for the book to reach the floor. I mean, we are only using the basic equations of motion, right? This is how the diagram is. The particle is only falling downward. Initial velocity here was 0 meters per second. This is obviously a free fall, so 9.8 meters per second square, and your distance is 1.5 meter. Right, in that case, what UAS, nothing else we have. And if I want to find out the time, we're obviously using the equation S equals to UT plus half AT squared. UT will be 0, so you end up getting the value for your T as 2s by a square root. So this is 2 1.5 9.8 square root. So you get 1.5 9.8. This is 0.55. So you get your answer as 0.55 seconds, right? And this is it for part A. After this, it says that student B suggests an improved model where the book is modeled as a particle experiencing a constant resistance to motion of magnitude r newtons, and given that the time taken for the book to reach the floor is 0.2 seconds. Now, using B's model, find out the resultant value for that r. Over here, object, I mean, in particle B situation also, object is accelerating, right? So I have to find out that acceleration now. But in this case, only weight was acting in the downward direction. Over here, for student A model, only weight was acting. That's why your acceleration is entirely 9.8. But in this situation, for student B's model, only weight is not acting. Over here, obviously, weight is acting in the downward direction, which is, by the way, a bigger force. But in the opposite direction, we also have a resistive force acting on the ball in the upward direction, right? So for this resistive force R Newton, it will not obviously accelerate at 9.8 over here. What will be the acceleration? I can again calculate that using the previous example. So same equation I'm using. S equals to UT plus half AT square. Both of them saw that book fall from rest, so UT is still 0. So over here, you can write the value for your A as 2s t square, so which is going to be 2 1.5. Time was given as 0.6, so you have 0.6 whole square, and that will be 8.33. Like, this is the value of your acceleration that you get, 8.33 meters per second square. And then using this acceleration, use the equation for your resultant force mass acceleration. Resultant force is what? Mg minus r equals to ma. So if you want to find out the value for your r, it's going to be just mg minus ma. So that is, weight was I think 0.2 Newton. So you have your 0.2, then 9.8 minus 8.33. So you have 0.2, 9.8 minus 8.33. So that is 0.294. So you can write 0.29 Newton. This is the magnitude of that result of that resistive force. Is this clear? Any problem from this part?
No, miss.
This was student B's model. Okay, then this is it for question 3. Now, if you move on to question 4, this is about moment, right? We studied this in the last class. So over here, this says that figure 1 shows a beam AB of mass m kg and length 2 meter. The total length is 2, suspended by 2 light vertical ropes. That means now they have tension here, right? Tension is acting as your resultant force, so reaction force this time. So tension from C, and this is your tension from D. Another thing, the ropes are attached to point C and D on the beam where AC is 0.6 as we can see, and dB is 0.4, 0.2. The beam is in equilibrium in a horizontal position. Equilibrium means all the balanced, like all the forces over here are entirely balanced. And also the weight of the beam was mkg. They're considered as a uniform rod. Uniform rod means obviously weight acts exactly from the center, right? So this is your mg. We skipped one line. It says a particle of mass pm is attached to the beam at point A, and the beam remains in equilibrium in the horizontal position. So there is a particle of mass pm which is hanging over here with the beam with a weight of pmg in the downward direction. Now they are saying that given that the tension in rope C is 4 times the tension in rope D, use the model to find the exact value for P. So if I consider this is x, this is going to be 4x, right? For tension in C is 4 times the tension in x, in tension in D. This is the idea. So if that's the case, we can use the resultant force calculation easily to find out an expression for P in terms of T, right? But they're giving us 7 marks. Let's just 1 minute. Consider for this kind of cases, I always have to modify my diagram. So I'll just copy this. In this case, if I use your equilibrium idea that, total resultant force is always zero. So resultant force being zero means upward forces are what? 4x plus x and then pmg plus mg. So we have like 5x equals to uh, pmg plus mg, right? We cannot add them together. So in that case, the value for your x turns out to be pmg plus mg divided by 5, right? So this is the value for your x, pmg plus mg over 5. Then after this doesn't actually give you the value for your p, this gives you the value for your x. So we're going to use this in a later idea, but now we can consider, no, actually this one only gives you an expression for, yeah, we cannot do anything out of this. Like now after this, we just have to use the moments idea. Like if I consider taking moment of about point C, right? If I start taking moment about point C, then what happens? Then I can see that A or that box or particle will make the beam move in the anti-clockwise direction. This is again clockwise direction. This is again anti-clockwise direction. So you have your answer as total moment anti-clockwise is equals to total moment clockwise. And for your total moment anti-clockwise, what do we have? We have your PMG as we're taking moment about point C, which is 0.6 meters away from C. So 0.6. Then again, these two were separated by what? 2 minus 0.8. So that is 1.2. So this is 1.2 meters away from each other. And so we get, by the way, this length, I mean, this, what is, if I simplify this, we have what value? PMG by 5 plus MG by 5, right? So we have your PMG by 5 plus mg by 5, and everything over here is multiplied with that 1.2. And then again on the clockwise side, your mg was acting, this was exactly at middle, so this is going to be 0.4 meter. So this is your mg 0.4. So now if you start calculating, so you have your PMG, which is now, by the way, what, 1.2 over 5, that is 1.2 over 5, that is 0.24. This is again 0.24. So add all the, like, PMG 6 0.24, which is 0.84. And then again take this to the right hand side. So you have 0.4, 0.24, that's 0.16 mg. So now after this, make P the subject, 16 and 84. Obviously at this stage we can understand mg cancels out. So divide by 0.84, that gives you 4 over 21. So this is the final value for your P. P is 4 over 21. Is there any problem from this part A?
No, teacher.
Okay. Then if we move on to your part B. Part B says that particle of mass P mkg at A is removed and placed by a particle of mass qm at A. The beam still is in equilibrium horizontal position and is now on the point of tilting. Obviously, it will tilt about point C, right? Because we are placing some large force at point A, so obviously it will tilt about point C. So TD will become zero. Tension at point D will become zero. Using the model, find the exact value of Q. So over here, then similar thing is happening. If you just copy this diagram, because everything is quite similar to this. Only difference is that now we have a QMG force. Everything else is similar. This is now entirely zero. So if this is zero, the only force here for this is in the upper direction is PC. So we can find an expression for TC also, but there's no point of it. Like I will just take the moment about point C. So if I'm taking the moment about point C, so moment about point C, again total moment, this is in the clockwise anti-clockwise direction, by the way, and this is in the clockwise direction, right? And this doesn't have any force, so doesn't have any moment. So this is your 1 minute anti-clockwise. Total moment anti-clockwise is what? QMG is at 0.6, and then again your mg 0.4, right? This is still that 0.4 meters away from C. So you get the value for your Q as 0.4. Mg cancels out with 0.6. So in that case, you will get your answer as 0.4, 0.6, which is 2 by 3. So you get the value of your Q as 2 by 3 kg. This is the mass of that particle. So this is part B. Then if we again quickly move on to your part C. In part C, they were saying it state how you have used the Modeling assumption that the beam is uniform. We always say that when the beam is uniform, obviously the center of mass or center of gravity of the beam is in the middle of the beam, right? Or is at the center, or is that like 1 meters from each end? That is your always assumption. Uniform is in the middle of the beam, right? This is it. Now we are done with your question four also. I don't have anything else to explain from question four. But this was A, all the working for A, and then again a separate diagram for B, and then again the definition for uniform. The definition for uniform is always going to stay same, right? This never changes. Just 1 minute. Okay, if we move to question five, then we can see this is a speed time graph. The speed time graph in figure 2 illustrates the motion of a car traveling a straight horizontal road at time t0. The car starts from rest and accelerates uniformly for 30 seconds, right? Okay, as we can see over here, it accelerates for 30 seconds and reaches a velocity of v meters per second. And the car then travels at a constant speed v until the time is t seconds. That means, by the way, this portion of travel is t minus 30, right? For the constant speed. Show that the distance traveled by the car from 0 to t seconds is like this expression. I obviously have to find out the what value, area under the graph, right? For area under the graph, this is the one parallel side, this is another parallel side, and height is capital V. So I just have to find out the area under the graph, which is, by the way, half t plus t minus 30 multiplied with v, which is 2t plus 15. So v by 2, then 2t minus 30. Take 2 as a common factor from the inside the bracket. So you have 2v by 2. That's t minus 15. So 2 and 2 cancels out, leaving you with vt minus 15. Right? This is exactly what the question was asking you to show. So we have proved it. Nothing else to explain over here, right? We just did the area under the graph calculation using the trapezium formula. Then after this, if we move on to your next part, now they're saying that the graph was given for a car, and they're saying the motorbike also travels along the same road. The motorbike starts from rest at time t equals to 10 seconds and accelerates uniformly for the next 40 seconds. That means if it starts at t equals to 10 and accelerates for next 40 seconds, that means when t is equals to 50, it will reach its final velocity. The acceleration of the motorbike is the same as the acceleration of the car, and the motorbike then travels at a constant speed for a further 10 seconds before decelerating uniformly until it reaches the v at t seconds. Okay, we have to represent all these things onto the graph paper. One thing to understand, if they are traveling at the same acceleration, that means this graph and this graph, they should be parallel to each other, right? Like over here, this is how the graphs are supposed to be parallel with each other. Otherwise, they won't have the same acceleration, right? So they should be parallel to each other. And again, thing, uh, Particle A, so your motorbike over here accelerates for a longer time, so reaches a larger velocity. So it then maintains that velocity for 10 seconds. So this is where the time is like, you're 50 seconds now. Then again, after this, maintains that for 10 seconds. And then again, after that, it will reach to the same velocity as the velocity of your car with that capital T seconds within that capital T seconds. Okay, so there's no point of writing this over here, but I can write that where 50 and 60 will be. This is your T is equals to 50. This is for the next 10 seconds, which is going to be 60. And this is your 10. Right, that's it. I don't have any other information for the motorcyclist. So this is for motorcyclist and this is for car. And after this, now they're saying, show that the constant speed of the motorbike is about 4v by 3. Is about 4v by 3. I exactly don't know, but I know that they were accelerating at the same rate, right? So if they were accelerating at the same rate and they both started with the initial velocity 0, so we can write down an equation that for part B, for car, if you write it down, that V is equals to U plus AT, right? Capital V becomes capital V. A is A, T is here 30. So you can write an expression for A as V by 30, right? This is just an expression for the acceleration of the car. Similar thing for the motorbike. You can use the equation V is equals to U plus AT. We do not know that, what is the final speed of the motorbike. So we'll just write this as Vm 0 plus A40, and you get your answer as A as Vm over 40. Right, remember that the both of them were accelerating at the same value. So if this is your equation 2 and this is your equation 1, where they're both referring to the same quantity, so we can write it substitute 1 into 2. So you end up getting your equation as Vm over 40, which is V over 30. And in that case, we can write down the speed of motorbike, that is going to be 4 by 3v, right? Take this to the right hand side. Obviously, it becomes 40 by 30, which is your 4 by 3v meters per second. So this is how you get the expression here. For part B is done. Then again, this is not like in part B. Part B was the graph. This is part C. Part C is done. Then again, after this, they were asking that at time t equals to capital T, the distance traveled by each vehicle is the same. So find the value of t. If both of them are traveling the same distance, we have already found out the equation for the distance traveled for the car. So now I have to calculate for that, what is this, for this motorbike. I can understand this one creates a trapezium and this one creates a separate trapezium, right? For the motorbike, if I draw the diagram again, this is how they create two trapeziums, right? This total length was your 4 by 3v, and this sense, or this side over here, was your 40 seconds. Oh no, sorry. The total base is, I think, 60, right? Yeah, 1 minute. 60, 50 is actually 50 seconds, and that is 10, right? So we have your 0 to 60, which is 50 seconds in the base, and this is your 10 seconds over here. Height is 4 by 3v, right? And then again, this 4 by 3v becomes the parallel sides of your second triangle. 4 by 3 and v, and height over here. This one is, by the way, t minus 50, an expression that I can get. We don't know for the rest of the time what was the times. It's just t minus 50. So for the motorcyclist, if I want to find an expression for the distance, motorbike, then it will be what? I mean, find out this area, which is half height is 4 by 3v, and then 50 plus 6 plus 10 is just going to be 60 here, right? Parallel sides is just 50 plus 10. And then adding this with half v plus 4 by 3v, and then again adding this further with t minus 50. So finally, what do we have? 0.5, then 4 by 3, and multiplied with 60, which is 40v. And then again 1 plus 4 by 3, which is 7 by 3, multiplied with 0.5, that is 7 by 6. 7 by 6, t minus 7 by 6 into 50, that is minus 75 by 3. Okay, 1 minute. 1 plus 4 by 7 by 3 into 0.5 into 50, which is 175 by 3 minus, and then 7 by 60. So you have 5, that is 40v. Okay, so this is an expression that you're going to get for the distance travel for the motorbike. Since I know that they are traveling the same distance, so I can obviously write their equations as equals to each other. So obviously we are getting what? 40v plus 7 by 6t minus 75 by 3, and that is equals to v is equals to, say, v t minus 15, right? That is an expression that we can get. Wait 1 minute. Find the value of t only.
Shouldn't it be 7 over 6 VT and 175 over 3V?
Oh, right. No, wait 1 minute. This is supposed to be v. Yeah, right. This was entirely v, right? 7 by 6 v. So over here it's supposed to be vt, and this is going to be 175 by 3 v. Yeah, that's why it wasn't making any sense. So we have 40 minus 175 by 3. So you get 55 by 3. 40 minus, okay, minus 55 by 3v, and then again 7 by 6 vt. So obviously now on the left hand side we have minus 55 by 3v and 7 by 6 vt. But still we have this like dv, all these cases. Let's just take everything to the same side. So we have like 15v minus 55 by 3v plus 7 by 6 vt minus vt 0. So we have like 15 minus 55 by 3, that is negative 10 by 3. 7 by 6 minus 1, which is positive 1 by 6 vt equals to 0. But still we have like two expressions here. Like we have two expressions like in terms of v and t. Even if I take v as a common factor, I'll get that answer in terms of t, right? Over here I'm supposed to calculate t exactly, not in terms of any values. So I think we're supposed to create any change over here.
Teacher, why can't we just
Mm-hmm.
cancel
Sorry, Asri, why can't we cancel what?
V? Because V is in all of them, right?
Achha, we can take v as a common factor, right? And then take it to the right hand side becomes 0. Then you have this 10, 1 minute, let me check. 10 by 3, 10 by 3, then again that will be divided by 1 by 6, which is just 1 minute. Let me just check if I created any problems over here. Half 4 by 3v multiplied with 60, because this is your base is 40 plus 10 is 50. 1 minute. Plus 10 is 60, and oh, this one is actually a problem. This expression over here was supposed to be t minus 60, right? Why is it t minus 60? Because over here, this time it took, like, whenever it is over here, it was like exactly 60 seconds, right? So this expression is your t minus 60, not t minus 50. Yes, obviously it took 50 seconds over here, but the value at this case was 60. So it will be t minus 60, not t minus 50. So we are supposed to get t minus 60 in this part, final part, right? If this is t minus 60, so we had 7 by 6 into 60, which is going to be 70v here, right? It will be 1 plus 4 by 3 multiplied with 0.5, which is 7 by 6v. And in that case, we get 40 minus 70 is minus 30, v plus 7 by 6 vt. So we get minus 30v. So we have minus 30v. So 15 minus 30, which is 15. Otherwise, the other cases are clear, right? Yeah, we have this 1 by 6. So I think 15 divided by 1 by 6 gives you the answer. So we can just take v as a common factor. 15 minus 1 by 6, t 0. So v vanishes. In the next line, we have like minus 15 minus 1 by 6t. So plus 1 by 6t equals to 0. And then again in the next line, we can get, just make t the subject of this formula. So it will be t as 15 divided by 1 by 6, which is your 90 seconds. Right, this is your entire maths. I think this is the end for you also, right? Yeah, this is the end for question 5. Okay.
This call is now being recorded.
Okay, so we're going to start with this question 6. This is again, I think, about your connected particles, right? This one says that particle of W Newton lies at rest on a rough horizontal surface. At rest means there is no acceleration or velocity, but all the forces are balanced, and rough means friction is there, right? These are the two informations we can understand from the first line. After this, it says the force of P Newton acts is as applied into the particle, and the force acts at an angle of alpha to the horizontal, where tan alpha is this. The coefficient of friction, the value for mu is 1 by 4, and given that the particle does not move, does not move for p less than equals to this value. I mean, less than means that the given that the particle does not move, show that when the value for this is less than this. Okay, we can first, well, basically we have to, like, find out the value for your p, right? So in that case, I first have to distribute the forces. You have your P, which is creating alpha over here. That will be broken down into what? By the way, this is moving towards the center. So we obviously cannot work within this plane. We have to take it to the fourth quadrant, where again it is creating alpha with the horizontal. Now it will have P cos alpha. Then again you have this with weight. It will have this P sine alpha. And then again you have a reaction force, and you have this friction, right? Mu r. Okay, so first thing I have to find out the value for your cos alpha sin alpha using that trigonometry part. So if the value for your alpha here is what? If the value for your alpha here is, sorry, tan alpha was 4 by 3, right? Opposite adjacent. So this is going to be 5. So your cos alpha is just 3 by 5 and your sine alpha is going to be 4 by 5, right? That's it. Now if I want to first find out the value for your, if the object is in motion or not, that means obviously I'm going to work with my horizontal plane, but the problem with my horizontal plane is that r is missing. That have to be calculated with my vertical plane. So if we calculate the vertical plane, then we have your what? Resultant force equals to 0, and you have your reaction force equals to weight plus P sine alpha. Sine alpha was 4 by 5, so we can write 4 by 5 P. Then again, the value of your friction is going to be 1 by 4 multiplied with weight plus 4 by 5 P. It turns out to be 1 by 4 weight plus 1 by 5 P here, right? After the simplification, this is the value of your force. Now after this, focus on the horizontal plane. If you remember the question, it says that show that the value for P are given that the particle does not move, right? Does not move, show that P is less than this much value. Like with the value of P less than equals to 5858 by W or 5W by 8, with this value of P, the particle will not move. If it is not moving, then what is happening here? Then obviously your resultant force is not greater than 0, right? It is something less than equals to 0. So resultant force less than equals to 0. If it was moving, then obviously the resultant force was greater than 0. That will give you some magnitude. If it is not moving, so obviously that is your less than equals to 0. This is how you create your inequality. And after this, then if you want to find out your, if you want to resolve the horizontal forces, in the horizontal forces, what do we have is that in the forward direction, you have your P cos alpha, which was by the way 3 by 5P now. So 3 by 5P plus your backward forces are just this friction, which is your 1 by 4 W plus 1 by 5P less than equals to 0. So this is going to be just simply give you 4P, I mean 4 by 5P and less than equals to, oh wait, 1 minute. Oh wait, this was actually minus, right? Because this was a resistive forces, sorry. Then it will be 2 by 5P, and if you take this to the right hand side, it will be 1 by 8W, so 1 by 4W. And then after this, P will be less than, 1 by 4W. This entire fraction will get inverted, 5 by 2. So 5 into 1 is 5, 4 into 2 is 8. So you end up getting P less than equals to 5W by 8. And this is what exactly the question asks you to show. Is there any problem from this part?
No, teacher.
Acceleration.
That's it for 7 marks.
Yeah, this is it for 7 marks, nothing else. Right, yeah, this is it for 7 marks. Nothing else you have to do over here. That's it. I think they're giving you marks like this: 1, 2, 3, and then 4, 5, 6, 7, 4 steps for this marks. Yeah, this is it actually. They don't have anything else to do over here. I was supposed to show that. We did that. Nothing else to show. I mean, over here. Okay, so then after this, if you move on to your question 7. Arif, do you have any problem from this question 6?
No, teacher.
Okay, then for this question 7 is about your connected particles. The Car of mass 1200 is towing a trailer of mass 600 up straight road as shown. Road is inclined, sine alpha is this. The driving force produced by the engine of the car is 3000. The car moves with the acceleration of this. The non-gravitational resistive forces of the car is 2r and the trailers are, the car and the trailer are modeled as particle, parallel and all these things. So that r is 60 and the tension in the 2 bar. Okay, first thing to do is to draw a proper diagram. This is your vertical plane of the trailer. Then again, sorry, this is another vertical plane of the car, horizontal plane of the trailer and car, and they were obviously connected with a tow bar. We'll obviously draw that also. And this is for the weight of the car or the weight of the trailer. Okay, so this is your 3000 G and oh wait, maybe I'm making a mistake. 1 minute. 1200 it's 600, sorry. 1200 G, 600 G. Car was moving a forward force of 3000 G and there's a resistive force acting on the car is 2R, right? Not only 2R, you have to understand if the car is moving forward, this trailer and the tow bar is actually holding back the car from moving forward, right? So in the resistive direction, you also have this tension. And then again, why is the trailer moving forward? Because the car is pulling the trailer forward. So obviously there is a forward tension acting in the trailer. So you have a P acting in the forward direction again. In the backward direction, you have your what force? 3000, and in the backward direction, you have R force, right? Yeah, sorry, I forgot that it was just R force. And again, if this is also alpha, then they're going to create, this is alpha, this is alpha. So it will be 600 G cos alpha, and then again 600 G sine alpha, and you have your what value? This is just reaction force, right? The problem is we already have R in the equation, so I will just write this. I don't even actually need this over here, right? We don't have to find out the mu R over here. So we don't need the reaction
Teacher,
force from the surface. Yes, Asri?
why did you label it as 600 G sin alpha?
Oh, sorry. This is going to be 1200, right? Yeah. 1200 G sine alpha. Then reaction force is not required, so I'm not going to consider that also. Over here, for part A, they were asking that show that the value for R is 600. For that, we're going to use this acceleration of the car. Right, the car was accelerating at 0.75. That means, wait 1 minute. But we still have, okay, if they're connected particles, that means both of them are accelerating with the same value, right? So if I want to write down the expression, like, all the forces acting on the car, then we have this 3000 minus 2r minus t 1200a, which is obviously 0.75. Then again for the trailer, we have just tension minus r is equals to 600, 0.75. So if I add the two equations, tension cancels out. You have 3000 minus 3r, then this one is going to be 1200, 0.75, then 600, 0.75. That is 1350. So you have 1350. And then again, after this, R is just going to be 3000, 1350 over 3. So you get your answer as 3000, 1350 over 3, which is 550. So you get the value for your R as 550 Newton. This was the calculation for your part 1. After that, for your part 2, they're asking for the tension calculation, right? For that tension, we can easily calculate 3000 minus 2R minus T is equals to MA, right? You can use the equation for the car only. The 3000 minus 2R minus T equals to 3000, so 1200. Oh, wait, sorry, wait. I think I made a mistake. I only distributed the horizontal force, vertical force, and we have to distribute this in the horizontal force also, right? That's why I was thinking that why are we not using that sine alpha over here? This was supposed to be cos alpha. This is supposed to be 1200 G sine alpha here. Then again, your 600 G sine alpha here. So in that case, this part we'll have to recalculate it, sorry. For the car, we have to use 3000. By the way, sine alpha, the value for that was 1 by 12. So we have this minus 2R minus T minus 1200, sorry, 1200 G with 1 by 12. And or we'll just write this as sine alpha. Then again, for the trailer, have to write the same expression. T minus R minus 600 G sine alpha, and then again same 600 0.75, right? Then tension and tension cancels out. You have like 3000 minus 3R. This is going to be minus 1800 G 1 by 12, and then 1350, right? So if you want to find out the value for your R, it's just going to be 3000 minus 1800 G 1 by 12 minus 1350 divided by 3. So you get your expression now as 1800. So 1 minute. 1800 9.8 into 1 by 12. Then again minus 1350 divided by 3. That gives you the value for your R as 60 Newton. Okay, if the value for your R is now 60 Newton, now you can easily calculate the tension in the tow bar by using 3000 minus 2R minus T minus 1200 G sine alpha, then 1200 0.75 expression, and after this you get the value for your T as 3000 minus 260 minus 1200 G 1 by 12 minus 1200 0.75. So you finally get your answer as 3000 minus 260 minus 1200 9.8 into 1 by 12, then again 0.75 1200. So you get 1000. The value of your tension in the tow bar was 1000 Newton over here. Is this clear? Any problem from this part 1 and 2?
No, teacher.
Okay, then if you move on to your next part. So your 1 and 2, this is A and B. After this, they're saying that the car and the trailer is moving at 12 and the tow bar brakes. Even after the tow bar brakes, the value for the resistive forces is unchanged, and use the model to find the further distance moved by the trailer before it comes to rest. That means exactly at the point where the velocity is 12, right? Both of the particle came, like the tow bar breaks in that case. So how far extra distance the trailer will travel? Okay. Use a model to find the further distance traveled, right? The further distance, not the total distance. Okay. So total distance would have mean that whenever the car was connected to the trailer, how much distance it traveled during that time. This is not interested about that. They're only interested when the tow bar breaks and how the trailer will decelerate. And within the deceleration, obviously it will travel up the slope. So what is the distance that it has traveled up the slope during that period? So in this case, for your part C now, the entire working is going to be focused on your trailer, not on the car anymore, because car has moved forward and only trailer was there. In this case, your tension is no longer there, right? On the trailer, there was a only forward force, which was tension. Now it is gone. So we only have that R and that 600 G sine alpha acting. Then again, in the finally downward direction, you have this 600 G. This is alpha. This was your 600 G sine alpha, and this is your reaction force, which is not required anymore. Now I have to find out your values for the deceleration. Okay, so for that you have to use the resultant force equals to I mean after the tow bar breaks, obviously resultant force equals to mass acceleration 6a, and it will be R is still 60 and this is 600. So these are resistive forces. It will have a minus sign. G 1 by 12 and then 600 A. So your value for A turns out to be minus 60 600 G 1 by 12 divided by 600. Right. So you get like the value for A as minus 11 by 12. Then if the value for A is now given, by the way, the point where the tow bar broke was the point where the object was moving with 12 velocity, right? So you have the initial velocity is 12, final velocity is 0. I have to find out the distance. So it will be v square u square by 2a. So we have to input the values 0 square, then 12 square, divided by 2 minus 11 by 12, and that gives you a displacement of 12 square to 11 by 12. So you get 78.54 meters. So you can write 78.5 meters or approximately 76 meters will also be accepted. Right? So this is all the work you need to do for your part C. Any problem from this part C calculation?
No, teacher.
Okay, then what is the next question? Okay, 1 minute. This is again from June 23, question 8. I forgot to write that at the top of the question. Over here, we can see that there's this box, and center of the box, we have this point O. This box is a what? This box is a square. And if just for curiosity, if I want to find out the diagonal, we can find out that using the Pythagoras theorem, right? Which is going to be 50 square, square root, 50 square 50 square square root, that actually 50 root 2 by 2 is going to be 25 root 2. Okay, like this one over here is 25 root 2. How do we got that? We got this using this idea. Root 2. Right, this is how we got this. Then again, before we move on, we can now move before we carry out with any calculations. It says that the square foot place ABCD with center O is modeled so that a flat horizontal surface measuring 50 by 50 is shown in 5. The direction unit vectors are I and J and are in the directions AB and AD. Okay, AB and AD means in which directions? AB, this is your I vector, and AD, this is your J vector, right? Okay. Then again, they are saying that all position vectors are given relative to O. Relative to O means that all position vectors will always start from that origin. Okay, that's what they're saying. And a small robot R is programmed to travel across the floor at constant velocity. And at time t, the R is at the point with position vector at it. So again, this one, position vector minus 2 plus j. it means that it was not exactly at one of the corners or on the circumference of your entire circular square board. It was at this point with respect to position O, right? Because all the position was given with respect to O. And at 11 second, R is at a point with position vector this. And at t second, the position vector of R is R meters. Now they're asking that in terms of t, I, and j, find an expression of R. First thing is that for this kind of cases, we always use those, okay, I'll just multiply velocity with time, right? Problem is that they haven't provided you with velocity because using this two, I have to calculate the expression for that constant velocity. So first thing is that if you start at minus 2i, right, minus 2i means what? If you use a vector quantity over here, minus 2i is somewhere here. But initially you are at this point. And then again, other value was given as 923. So originally you were here and then 923 is somewhere here. So this is how you can create a triangle, right? And using this triangle, we can find out that, okay, what will be the velocity in this case, because this change in displacement over time gives you the velocity also, right? So if I just draw a diagram, this displacement was given as minus 2i plus g. And this is what displacement? This was your R naught, right? And your second displacement was what? Again, with respect to your origin, like this displacement was given as 9i plus 23j. And it traveled to that second displacement. Just 1 minute. It traveled to that second displacement. Again, this is the point of origin with that constant velocity vt value, right? Maybe in this direction. This is how you can connect them. So I can understand that, okay, now if I want to find out the value for your v, how will I create the equation? We always create the equation creating on that which lines are following the same direction, like from O to this point, from this to this point, they are actually traveling in the same direction, right? As you can see, without picking up my cursor, I can connect these two lines. That means they are traveling in the same direction, but for this line, I will have to start from O again. So this is in the opposite direction and they are in the same direction. If that's the case, then I can easily write that your Vt plus R naught is equals to this displacement. Okay, let's consider this as R1. So we are trying to find out Vt. So we get R1 minus R naught, and obviously T will become in the denominator, right? So if I want to write an expression, that's why I always say do not memorize the formula. In most of the cases, we see that I always have to find out R1, right? So we'll just keep the equation like this and try calculating. But over here, I was looking for V, so I have to do the rearrangement. For the rearrangement, I have to understand how the formula works. So if I now calculate the values, which is 9i plus 23j minus, it was already minus, we have a minus here, so it will be positive, 2i, but this one becomes negative, minus j over 11. So 9 plus 2 is, I think, 11 already. 9, 10, 11, yeah, 9, 11. Sorry, 11i, and 23 minus 1 is just 22j over 11. I can take 11. I can take 11 as a common factor from the numerator. So we get like I minus 2j divided by 11. So 11 and 11 cancels out. You get the final value for your velocity as I minus 2j, right? This is again not something which I was looking for, but I had to calculate it. So it will be v as I minus 2j. Is it minus? Sorry, no, it's plus actually. It's plus I plus 2j meters per second. Is there any problem from this first part?
No problem, teacher.
Now, again, it doesn't stop over here. It says that it will travel with some r vector, which I do not know, and I have to calculate for that, right? If I have to calculate for that, this is just an expression to calculate the velocity. This was not everything that the question was asking for part A. Now we will find out the expression for that displacement r. For that displacement r, again, they would travel the same kind of pattern. right? We have the initial displacement is always same, right? R naught is always 2I plus 3j. That will not change. There's no point of changing this one. This is your R. And how do you reach to that R? Using that constant velocity multiplied with the t times, right? We don't know the time. It just says that in order to be in that R position vector, it took t seconds. So we're just going to write that, okay, then we have like 2 plus I plus 2j multiplied with t seconds. And this was your origin. And again, these two add together to give you the value of your R. So you can write R naught plus Vt. So 1 minute. R naught is minus 2I plus 3j. And then if you multiply t with this, you get ti plus 2tj. So just add the I together and j together. So it will be t minus 2I. I don't want to keep the minus in front. So that's why I keep that positive things in front. And then 3 plus 2tj, and this is the expression. T minus 2, 2t plus 3. Or was, oh, sorry, this was not 3. This was just 1. Sorry. This was just 1. So it will be 1 plus 2. Right, this is it. This was the final expression for your R that they were asking for. That find the expression for R in terms of t. So that's just going to be R naught plus Vt. Since V was missing, that's why we had to carry on with this extra work where we calculated the value for V and then used it over here in this expression. Any problem from this part A?
No problems, teacher.
You don't need to draw the diagrams. The diagrams was only there to help you guys understand the ideas. Then again it says that now there's this saying that this a second robot is who is at point C, who is originally starting at point C now. Okay. And now they're saying that at t equals to 0, S leaves C and moves with constant velocity of this. And at t seconds, the position vector of S is S meters. Write down in terms of t, I, and j the expression for S, like how far it will travel after the t seconds. One thing to understand that everything was with respect to your position vector O, right? So that means if something is starting from C, so how do you get to C? Either in this way or in this way, right? I mean, but this kind of robots, they cannot actually travel in this angular way. They have to travel to C by traveling 25 meters in the I-axis, 25 meters in the J-axis. That's how they travel. Because from point O, they're all starting. So that is half of the 50 meters, so 25 meters in the I-axis, 25 meters in the positive J-axis. So you have to say that since robot S was starting from point C, what is the position vector of point C? It's 25I plus 25j. The initial position vector R naught for that robot S at point C is 25I, 25j. Is this clear how we calculated the initial R naught for robot S?
Yes, teacher.
All this time over here, I was working with robot R. Okay, now we are working with robot S. Robot S is a constant velocity already given, so I don't have to work with that. I just have to work with that part B is that robot S is starting from C, and with that ij velocity, it will reach somewhere over here. Like this is how it will create a entire motion. This was at point C. This one was 25I. This is your R naught value. Write this over here. This is your origin, and you are traveling to this point specifically after t seconds, which has the displacement R, and it's going to be just Vt. Vt was what? Negative I, negative j. So you just have negative I, negative j, t. Right? That's just it. Now use your idea. I can understand that this line and this line, they are in the same direction, and that R is in the opposite direction. So obviously we have the equation as R naught, Vt. So you get your answer of R naught as 25I, 25j, and we're going to add this plus let's just remove the brackets. Okay, so we have like, minus I minus negative ti and then again tj. So if you add them together, you have like 25 minus t I and then 25 minus t j. This is the expression that I can get, 25t, 25 minus t. After this, again, oh sorry, this was not r. They were referring this displacement as s, okay, because r was used for robot r. So whatever they are using, we have to use that statement. So we should also write this as s naught, right? The initial vector for the robot s. And then we have robot s and everything. After this, now they're saying that show that SR can be written like this. SR can be written like this means R that you have calculated over here, this R, and then S means this S. Now for your part C, you are considering that okay, after traveling, like after 3 seconds, whatever the any final position vector R, right, it was actually at I don't know where because the t value is unknown. So we'll just create an equation. This is your origin. After t seconds, maybe robot S, robot R moves to this distance and robot S comes to this distance. So this is your position vector R and this is your position vector S. Right? They were asking what? They were asking SR, right? From S to R. So this is how the direction will be. So I can clearly understand. Over here, we have OS and SR in the same direction and OR in the opposite direction. So we can write OS plus SR in the same direction equals to OR. Sorry, yeah, OR. So if I want to write an expression for SR, it's just going to be OR minus OS. So we write this as S minus R, which we calculated in the previous part. If you include the expressions, we have 25 minus ti, then again 25 minus tj, and then after this is just for s, right? For r, we have 2t minus 2i and then t plus 2i. Just 1 minute. I'll just copy this entire expression. It never changed. Wait, am I making any mistake? Yeah, I am. It was supposed to be r minus s, right? So you will have this one exactly in the negative case with that r being positive. So I'll just include a bracket over here. So you have a minus in front of that s, which makes everything inside that s negative. So if you have everything inside that s is negative, so you basically get, okay, we have like t minus 2 I, then we have plus 1 plus 2t j, then you have this minus 25 minus ti. This one is also negative 25 minus t j. That means we're actually subtracting these values, right? If you now remove the bracket, you have t minus 2 minus 25 plus t. This is everything in I. Just 1 minute, minus 25 plus t. Yes, and then again 1 plus 2t minus 25 plus tg. So add all this together. We have 2t minus 5, 6, 7, 27i. And then again, we have your 3t minus 24. Sorry. 3t minus 24g. And this is your final expression, right? This is the final value for SR. All this time, you have to write that we are calculating SR, right? SR. Okay, try to identify, is there any problem from this part? Is there any problem from this part?
Can you explain the C part again?
Hmm. I think the diagrams were not understood.
Right, teacher?
No, I was saying I think this diagram was a little confusing, but you just have to think about this way, okay? Whatever you calculated so far, that is not your concern. You were just trying to, or we can also use it in this way that okay, you are starting from the center. C is your like, this is your origin from O to this is where R was ending its journey, right? This is how you started from it. This is how you started. So you had this value as your minus I plus it was minus yeah sorry minus 2I plus J, right? This was your R naught. Then you got the velocity over here as your velocity was what, sorry, 1 plus 2J, right? I plus 2J, then multiplied with your time, right? Then you got your answer over here as R, which turned out to be this one, right? That was the value for your R. This is the value for your R that you got, right? Which is, we understand this. Now we are working with S, right? I'm just going to roughly draw this so that, they're separately from each other. So maybe S was traveling this type of distance, which is not true, but I'm just saying this. I think maybe S was traveling this type of distance. S was at an initial, this was R naught, so this is going to be S naught, which was your 25I plus 25J, right? This initial vector. Then after this, you had this Vt, and Vt was your, for this one was negative I, negative J, negative I, negative J, T, right? And after this, S also got to this S displacement, which was your 25T. This is S25 minus Ti, and then 25 minus Tj, right? So what you want to find out is that, okay, this is the R vector, this is the S vector. You now want to connect them, okay, and try to find out that what is the position vector of S and R within that T, within the T hours, right? This is what you want to find out. This is the SR that you want to calculate. Is this clear?
Yes, teacher.
Any problem from anyone else? What is SR? Arif, Fayad,
No, miss.
right? And that's what we calculated. In this diagram, you can see that whatever we have calculated so far, sorry, everything is written on this diagram. But whenever I'm working, I can already understand that we have calculated R already, we have calculated S already. So why bother drawing this black triangle for robot R, red triangle for robot S? We just want to focus on this blue triangle. That's what we did here. This was your S, this was your S over here, this was your R over here, and SR is over here, right? This is your SR vector. Problem is that S and SR are combined together to give you R. So if I rearrange them, it's going to be R minus S. This is your R minus S. Rearrange them. Finally, you're going to end up something like this. That will be the final vector in terms of T for SR. Any problem from this part?
No, miss.
Can you
Okay, now,
explain the
mhm.
triangle right below C?
Sorry, Asri, couldn't listen.
The one where it wrote R to R, R to S.
I'm really sorry. Repeat again.
Um, the triangle where I've written R to R and R to S, like to the left of the
This one.
cursor. The diagram, the triangle.
Oh, this one.
Yeah.
In this case, what? I mean, over here, everything is always from the origin, right? After T seconds, robot R traveled this displacement. After S seconds, robot S traveled this displacement. So if I want to find out that how far robot R was from robot S, with after T seconds, I just have to find out this one. And again, they gave you the idea. It was SR with this arrow. That means what? You are traveling from S to R, right? And those R and S was also from origin to this point, from origin to this point. That's how you assign the directions to this vector diagram. From origin to this point is your S, from origin to this point is your R, and from S to R, from S to R is your SR. So you can clearly see that OS and SR kind of is traveling in the same direction. If you want to add your OR to this, I have to pick my cursor and start from OR again. So obviously they are not in the same direction, right? As you can see, this is in this direction and both of them are in this direction. So OS SR gives you OR. That's what we wrote over here. Is this clear?
Yes, teacher.
Okay. Then this is not it. We have to maybe find out the values of something. They're saying that find the time when the distance between R and S is minimum. But this kind of cases, whenever they say that, okay, the distance between them is minimum, minimum means that their distance between, again, they're saying that distance between them is minimum, right? So first thing, what you got is the expression for your displacement. Oh, wait. So we don't have much space, so we will continue the rest of it part over here. Let's continue it over here. We won't need that much space. For D, what you got for that SR vector is actually the displacement, which is in the term of your 2t minus 27 I vector, and then again 3t plus 24 j vector. Okay, so if this is your ij vector, then we have to work with your distance. Distance is the magnitude of your displacement, right? So we have to find SR, which is, by the way, 2t minus 27 square, 3t minus 24 square, everything under the square root. So if you do the simplifications for it, wait 1 minute. Let's not do the simplification because we have a square root and all. Let's just consider that, okay, this is a square and keep the square over here. So you will get an expression for d square. If you break this down, what do you have? 4t square. 4 into 27 is 100. 8t, 27 square is actually positive 729. Then 9t square, 324 2, which is 100. 70, 76. Simplify this, you get 13t square, that's plus 36t, which is 1305 d square, right? Now this is an expression which you get for, wait 1 minute, am I making it? Negative 108, 144. This is 3, 224, 3, 224, and then 2, 227, that's 108. So this was also negative, right? So that way we get 108 and 144, which is 252. Sorry, it will be 252t and 1305. So this is the expression that you get for your d square. In this question, they're saying you have to find the value for your t when the distance between them was minimum, right? So what do we understand by minimum distance? Just 1 minute, please. Yes, sorry, as I was explaining that over here we get the expression. But whenever they say that distance is minimum, right? By the term minimum, maximum, what do we understand? We always understand that if this is a quadratic equation and I want to find out the minimum point, I always understand that at that point, this is a turning point, and at the turning point, dy by ds is going to be 0, right? So we get d square dd square by dt, and that will be 26t minus 252, and this is equals to 0. From there, the value of t is going to be 252 over 26, which is 226. That is, I mean, in decimals, you get 9.7 approximately. This is 9.7 distance. So 9.7 seconds. But they are only asking you for time, so we'll stop here. In some questions, they might ask you that also find out the distance. Then what we will do, I will use this the 9.7, insert it over here with a square root to get the distance, right? In this case, they never asked you that, but if they would, I would have to, like, include calculating this. 252, 9.7, then 1305, and everything with that square root, right? Then I will get the value for your display distance also, which they didn't ask here, but we are just calculating this just for your clarity, which is 5, which is 9.15 meter. Okay? This is how we would have calculated them. So 1 minute. Is this clear? Any problem from this part D?
Yes.
No, teacher.
Okay, then